Now for our second example, we want to look at the boat again. This time we're going to let that same displacement, the same problem last for 6 seconds. So remember when we were looking at this, we had our boat here with our sail, and then we had some wind going this way with 2,000 newtons of force. The boat was 1,000 kilograms heavy, right? And then there was some hull drag, some water resistance. At 1,500 newtons. But now we know that it's 6 seconds. We can use the result from the previous part to figure out what the final speed is, how fast after the gust is over. Okay, so we already did this in the previous video, so you can look at that, but remember we took these two drags, or these two, well they are both drags, but these two forces. The minus sign means the water resistance is backwards, and there's no minus sign on the sail because the wind is pushing it forwards. So these are imbalanced, so we took our values, substituted them in here, then we divided by this 1,000 kilograms after we did the subtraction and ended up with 1/2 meters per second squared as our acceleration. So with that, we can find our velocity, our final velocity. So actually we'll use A is equal to delta V over T, delta T, that's what we used previously. Delta T here is just the 6 seconds. But delta V we said was the final velocity, that's what we want, minus the initial velocity, that's this 5 meters per second, all over this delta T, which we said was 6 seconds. All right, so from over here we have this 1/2 meters per second squared is equal to the VF that we want minus the original velocity, 5 meters per second, and we divide that all by 6 seconds, the amount of time the force is applied. So I guess the first thing to do is multiply everything by 6 seconds, so we end up with 3 meters per second, so 6 seconds times 1/2 meters per second is 3, is equal to VF minus 5 meters per second. Sort of means we can add plus 5 meters per second to both sides. So we end up with 5 plus 3 is 8 meters per second. Is equal to VF. And just reiterate that by making it equal to 8 meters per second on the other side. It doesn't matter which side it is, but it's a little bit easier to read VF is equal to 8 meters per second than 8 meters per second is equal to VF. They have the same meaning, but this just tells us exactly what we want to say is that after the gust, the speed of the boat is VF, and that VF is 8 meters per second, right? So to solve this problem, first we have to solve the force imbalance problem to find the acceleration. Then we come over here and use that acceleration to find what we don't know, which is this VF. So and a little bit of math gets us the rest of the way. Yay, math. All right, so there we are. That's example 2. Next I'll talk about what happens if the force is not in the direction of motion, like in this case. What does that mean?